Hello everyone. In this lecture, I supplement the content of Chapter 7 of the textbook, which covers how to manage project risks. The COVID-19 pandemic is an example of a risk with a low probability of occurrence with devastating human and economic impact when it occurred. The tolls, however, could have been much lower if the pandemic risk was identified and planned for in advance. The learning objectives are to understand a project risk management planning framework, which includes risk identification, risk analysis techniques, risk response strategies, risk monitoring and control, and finally, risk evaluation. PMBOK defines risk as an uncertain event which can have positive or negative impact on project objectives. And note that risk is not always negative and sometimes can be an opportunity with a positive impact on the project. Similarly, PMBOK defines project risk management as the processes of conducting risk management planning, identification, analysis, response planning, and monitoring and control of a project. The objective of risk management is to increase the probability of impact of positive events while decreasing the probability and impact of negative events. Since risk changes throughout the project, most of these processes need to be updated and repeated throughout the project. Because of their failure to plan risk management, many organizations find themselves in a continual crisis management or firefighting mode. The project risk management planning framework provides a structure and processes for managing IT project risks. This framework includes planning, including determining who's responsible, who are the stakeholders, how frequently the plan needs to be updated, identification of risk in terms of threats and opportunities, analysis of risks in terms of their impact and their probability of occurrence, and strategies to minimize or eliminate negative impact of the risk or taking most advantage of a positive risk. Monitoring and control as we implement risk strategies and adjust as needed, and evaluation of our risk responses. So let's look at these steps more closely. In the first step, we create a risk management plan to minimize the negative impact of risks while taking advantage of opportunities. For creating the plan, we need to involve all key stakeholders and communicate the final plan to gain their support and their buy-in. Risk identification can be difficult because many risks can be caused by different sources and can affect a project in different ways during different phases of the project. The framework facilitates identification of risks by focusing on risks to project goals and project MOV, for example, lack of sponsor support, risks to project objectives in terms of scope, cost, schedule. For example, scope creep is a risk in this area. Internal versus external risks. Internal risks are those risks that the project manager is directly responsible for and are under the direct control of the project manager, such as lack of a particular skill set of a team member. External risks are risks that arise from environment outside of the project and which are not under the project manager's control. An example would be if an earthquake takes out a major supplier and causes the prices to go up, that would be an external risk. At times, the distinction between internal and external risk is not so clear. For example, when a project manager chooses an unreliable supplier because of an inadequate investigation of the qualifications of the supplier, in this case, the risk really is a result of an internal process. Considering risk categories can also help us identifying risks. Known risks are events that are going to occur. In short, these events are like death or taxes. They will happen and there is no uncertainty about it. Known unknown risks are identifiable uncertainties. For example, if you own a home or rent an apartment, you know that you will receive a bill for utilities every month. The precise amount you will owe to the utility company will be unknown until you receive the actual bill. Unknown risks, sometimes referred to as UNC, are residual risks or events that we cannot even imagine happening. For example, in 2019, people did not know that there would be a worldwide pandemic that impacts every aspect of our lives. Unknown risks are really just a way to remind us that there may be a few risks remaining even after we think of all the other risks. In general, these are the risks that we identify and react to after they occur. Risk may be unique to a particular phase of the project. For example, risks associated with going live stage of the project, which would be part of the execution phase. There are several tools for analyzing and assessing project risk. It's important to choose the right tool for the right job and not try to use a single tool for all situations. Learning cycles is when the project team and stakeholders identify the facts that they know, the assumptions that they think they know, and research items that they need to find out more about. They use this to identify various risks. Using these categories, the group can create an action plan to test assumptions and conduct research about various risks. Brainstorming encourages contribution from everyone in the group. Initially, ideas must be generated without being evaluated. Once the ideas are generated by the group, they can then be discussed and evaluated and combined by the group. Delphi technique is when we have a group of experts that are asked to identify potential risks or discuss the impact of a particular risk. Initially, in order to reduce the potential for bias, the experts are not known to each other. The responses are collected and made available anonymously to each other. The experts are then asked to provide another response based upon the previous round of responses. The process continues until a consensus is reached. The advantage of using Delphi technique is the potential for getting insightful views into a threat or opportunity. But the process takes time and may consume a large portion of the project resources. Interviewing various project stakeholders is a technique for identifying and understanding the nature of risks from various points of views. But the quality of information derived from interviewing depends heavily on the skills of the interviewer and the interviewee, as well as the interview process itself. Past projects, SWOT analysis, and fishbone diagrams are other identification tools that we will look next. Checklists provide a structured tool for identifying risks that have occurred in the past projects. They allow the current project team to learn from past mistakes or to identify risks that are known to a particular organization or industry. One problem with checklists is that they can lead to a false sense of security in the sense that we checked off each of the risks on the list, then we should have covered everything. SWOT stands for strengths, weaknesses, opportunities, and threats. Brainstorming or any group techniques can be used to identify risks by categories of risk using the 4 parts framework. The usefulness of using SWOT analysis is that it allows the project team to identify threats and opportunities as well as their nature in terms of project or organization strengths and weaknesses. Strengths and weaknesses are generally focused internally, while opportunities and threats are focused externally. These could be risks associated with any of SWOT items. The fishbone or Ishikawa diagram is used to analyze the causes of poor quality in manufacturing systems. The diagram can also be used for understanding the causes or factors of a particular risk, or as well as its impact. This is an example of Ishikawa diagram which shows the possible causes and effects of a key member of the team leaving the project. This technique itself can be used individually or in a group setting by using the following steps. Identify the risks in terms of a threat or opportunity. Identify the main factors that can cause the risk to occur. Identify detailed factors for each of the main factors. Continue refining the diagram until satisfied that you have captured all the factors. Risk analysis and assessment provides a systemic approach for evaluating the risks that the project stakeholders identify. The purpose of risk analysis is to determine each identified risk's probability of occurrence and its impact on the project. The expected impact is then calculated by multiplying the probability and the impact. Risk assessment, on the other hand, focuses on prioritizing risk so that an effective risk strategy can be formulated for those risks that require a response. Keep in mind that we can't respond to all risks, and risk response depends on the stakeholder and organization's risk tolerance. For example, many large organizations, such as the federal government or Chevron Corporation, don't buy insurance for rental cars because of being self-insured, or being self-insured is more cost-effective. In qualitative approach, we make subjective assessments based on experience or intuition. There are several techniques for qualitative analysis, including payoff table, decision tree, or risk impact ranking. Let's look at some examples for each of these techniques. This is an example of a payoff table for a scheduled incentive program, which has a $200,000 payoff if the project completes the project 20 days early, or on the other end of the spectrum has a $40,000 penalty if the project is completed 20 days late. You can see the amount of incentives in between. Then for each scenario, we need to determine the probability of occurrence. The expected value is then calculated by multiplying those two. As you can see, the total expected value of this incentive program is $88,000. This is another example of a payoff table for gambling. If you have a 1 in a million chance to win $8 million, then the expected value of winning is $8 each time we play. By calculating the expected value of losing, which is very close to our bet of $10, then the expected value each time that we play is losing $2. A decision tree provides a visual or graphical view of various decisions and outcomes. The advantage of using a decision tree includes the ability to make better decisions because we are informed not only by the magnitude of possible outcomes, but also the probability of their occurrence. In this example, the project manager is using the decision tree to decide whether to do full testing, which costs $10,000, or limited testing, which costs $8,000. In either case, the product can pass or fail. In case it fails, it will require additional costs to fix it. By calculating the expected cost for each branch of the decision tree, we can see that full testing approach is less costly than the limited testing approach. The purpose of risk impact table is to analyze and prioritize various risks. It provides a mechanism for determining which risks should be monitored and which risk may require a response. In this example, we see that the expected impact of response time not accepted to user client, that particular risk has the highest expected impact and therefore the most critical risk for this project. Risk ranking table simply puts all the risk in the order of magnitude of their expected impact. Risk probability distribution can be discrete or continuous. Discrete probability distribution is for risks that have a single probability. Continuous probability distributions are for modeling an event that has infinite numbers of possible values within a stated range. Some of the most common distributions are normal, PERT, and triangular. An example of discrete risk distribution is for forecasting the probability of a head or a tail in a coin toss. Head or tail each have 50% chance of occurrence. The normal distribution is continuous distribution, and its shape is determined by its mean and standard deviation. When graphed, the normal distribution forms the familiar bell-shaped curve. As an example, for calculating life insurance risks, we need to consider age, which generally has a normal distribution. In this kind of distribution, about 68% of all values fall within one standard deviation from the mean, while 95% fall within 2 standard deviations and 99% fall within 3 standard deviations. The PERT distribution is also a continuous distribution and looks like a skewed normal distribution, and described by 3-point estimates: an optimistic estimate, a most likely estimate, and a pessimistic estimate. As we have discussed in the estimating chapter, PERT mean is the weighted average of the 3 estimates, with the most likely estimate weighted 4 times the most optimistic or most pessimistic estimates. The triangular distribution is based on the same 3-point estimates as PERT distribution, but with equal weighting for all 3 estimates. When we have a random event, we can use simulation techniques like Monte Carlo simulation, which randomly generates specific values for a variable with a specific probability distribution. The same approach can also be used to analyze and understand how different input variables like task duration can impact some output variables like project completion. MS Project does have there are add-ons for it to do the Monte Carlo simulation. Monte Carlo simulation goes through a specific number of iterations or trials and records the outcomes. We can perform simulations using almost any continuous or direct probability distribution. If one was attempting to develop a budget in the face of uncertain prices, a Monte Carlo simulation could be conducted that would make random picks from probability distribution. One then might run 1,000 simulation picks, generating 1,000 budget estimates that could then be averaged to calculate the expected budget cost. The results of a Monte Carlo simulation can be displayed as a cumulative probability distribution. We can then easily find the probability associated with any outcome. In this example, the mean of 17.7 days has about 40% chance of occurrence. Tornado diagram is another tool for illustrating the sensitivity of a project outcome to various risks. In this example, we see how sensitive the project cost is to the risks that were identified. This tool is used extensively in the oil business as they are looking for various projects and various explorations. After we analyze the risks, then we need to develop strategies to to address those risks that the project stakeholders determine requiring a response. The strategy to respond to a risk depends on the nature of the risk, whether it's a threat or an opportunity, the expected impact of the risk, the constraint of the project, and the risk tolerance of stakeholders and the organization. The strategies for risks that offer opportunities are to exploit it or take advantage of the opportunity, or share the ownership of the opportunity with customers or vendors. In either case, it requires awareness on the part of the project team to be able to recognize and take advantage of opportunities. The strategies for risk that pose threat to the project include ignore or accept the risk if it has low expected impact. These are more passive approaches to risk response. The project stakeholders can either be hopeful that the risk will not occur or just not worry about it unless it does. When the risk occurs, they can be addressed through either management reserves, which are controlled and released by senior management. These reserves are not usually included in project's budget, but provide a cushion for dealing with unexpected events. They can also be addressed by contingency reserves, which are usually controlled and released by the project manager when a particular risk occurs. The reserve is usually included in the project's budget. Or it can be addressed by contingency plans, sometimes called alternative plan or plan B. This plan can be initiated in the event a particular risk occurs. Although these types of plans are viewed as plan of last resort, they can be useful in a variety of ways. Another strategy is avoidance strategy, which focuses on taking steps to avoid the risk altogether. In this case, an active approach is made to eliminate or prevent the possibility of the threat occurring. Mitigate strategy focuses on lessening the probability and or impact of the threat if it does occur. Transfer strategy focuses on transferring the ownership of the risk to someone else. This transfer could be in the form of purchasing insurance against a particular risk or subcontracting a portion of the contract work to someone who may have more knowledge or expertise in that particular area. As a result, this strategy may result in a premium or added cost to manage and respond to this risk. Risks must be monitored and controlled in terms of having an owner assigned to every risk. If a particular risk does occur, the owner of that risk should be empowered to act in terms of deploying resources and appropriate risk strategy. There are several monitoring and control techniques. The first one is risk audits that ensures that the project manager and the team have done a good job of identifying and analyzing project risks and on ensuring that the proper procedures and processes are in place for dealing with risk. Risk audits should be conducted by people outside the project team. Using outsider provides a fresh perspective. The project team may be too close to the project and miss significant threats or opportunities. Another approach is risk review which is normally conducted internally by the project team. Throughout the project cycle, the project stakeholders should hold scheduled periodic risk review meetings. These reviews should be part of each team meeting and part of the project team's learning cycle. Risk status meeting and reports should provide a formal communication system for monitoring and controlling project risks. The results of risk strategy development is summarized in the risk response plan, which should include the project risk, the trigger, which is the flag or metric for whether a particular threat or opportunity has occurred, the owner of the risk, who will monitor and responds to the risk when it's occurred, and also will make regular reports to the project manager or project client. The risk owner has to ensure that the adequate resources are available for managing and responding to the risk. The outcome of the risk response can be either favorable or unfavorable. Therefore, a great deal can be learned about the entire process of risk management by evaluating the response. Lessons learned can lead to the identification of best practices that can be shared throughout the project organization. In summary, lessons learned and best practices help us to increase our understanding of IT project risk in general, understand what information was available to managing risk and for making risk-related decisions, understand how and why a particular decision was made, understand the implication not only of the risk but also the decisions that were made. Learn from our experience so that others may not have to repeat our mistakes. Some of the common mistakes that project managers make in managing risk include not really understanding the benefits and advantages of risk management, not allocating adequate time or resources for risk management, and not following a systemic approach for identifying and assessing risk. So this concludes my lecture on Chapter 7. Thank you for your attention.